In this video, we will present the concepts associated with encrypting data for transmission across the network, particularly across the Internet. Data which is transmitted across the Internet is open for everyone to see. Hence, to maintain the security and integrity of the data transmitted across the Internet, it is always encrypted before it is sent. In this video, you will learn how this is done. Let's begin by defining a few terms. Encryption is the process of altering the data so that it is unrecognizable. Information or knowledge cannot be extracted from encrypted data. It is secure. Decryption is the process of removing the encryption and restoring the data to its original form so that it can be understood. Encryption algorithm is the mathematical transformation of the data that encrypts it. And the encryption key is the method that the algorithm uses. Because it is more efficient to use the same encryption algorithm for encrypting data, there has to be a way to make each encryption unique. The method to do that is to use an encryption key that changes. The encryption algorithm uses the encryption key to produce a unique encryption based on that key. There are two types of encryption that we will discuss. One is called symmetric key encryption and the other is asymmetric key encryption. Symmetric key is also referred to as single key encryption. Asymmetric key encryption sometimes is called public key encryption. Symmetric key encryption, as shown in this slide, uses the same key for both encryption and decryption. It is effective and rapid. To ensure a secure transmission, symmetric keys can be made very long and very strong. The problem with symmetric key encryption, especially over the Internet, is how to distribute the symmetric key and to keep it secret. For example, I want to buy something over the Internet with my credit card. How do I send my encryption key to the online store? If I send it in plain text, someone else can access it. And then, even though my credit card number is encrypted, others can access. Asymmetric key encryption uses different keys for encryption and decryption. It uses one key for encryption and a different key for decryption. The encryption key is often called the public key because it is well known to everybody. The key used to decrypt the message is private or secret, and only the originating organization knows it. So, for example, if I want to send my credit card information to a company like Amazon, I encrypt it with their public key. Since that key is public, everybody knows it, and it's easy to find and use. Amazon then decrypts the message with their private key, which nobody knows except them. These asymmetric encryption algorithms are powerful and unique. The key that is used to encrypt the message cannot be used to decrypt the message. In other words, on this diagram, the flow of operation can only go from left to right or from right to left. It can't go halfway and then return. In other words, once the message gets encrypted, it cannot go back the way it came. Obviously, with symmetric encryption, as shown on the previous slide, the flow can go in either direction. Now suppose that some organization wants to send you a message. And it is important that you are sure that it's from that organization, not from some other group. You need to know for sure that the document you receive is genuine and is from the organization that you expect it to be from. You want to make sure neither the document nor the sender are fraudulent. In this case, that same asymmetric encryption is done, but it works backwards. The organization encrypts the document with its private key, and you decrypt it with the public key for that organization. Because you know the public key you have is from that organization and it works to decrypt the message, you can be sure that the document is genuine. The only private key that works with that public key that you have is the secret key used by that organization. Now suppose you have a similar need either to send some personal information such as credit card number or to receive a secure document, but you don't know that organization's public key. In other words, you are buying something online, but you don't know the public key for that online store. How do you get it so you can encrypt the data? You could just request it, but how can you be sure that somebody doesn't intercept your message and send you a fraudulent public key? How can you be sure you're getting the right public key for that organization? This is done with a digital certificate. A digital certificate is an encrypted document that contains the organization's public key. Since the certificate is encrypted and signed, you can be sure that it is authentic once you get it decrypted. So who encrypts the digital certificate? The digital certificate is encrypted with a public key of a certifying authority. The certifying authority is a well-known organization with a well-known public key. In fact, all browsers have lists of certifying authorities and their public keys. Digital certificates are encrypted with the public key of one of these certifying authorities, and thus the browser can decrypt it and extract the public key of a specific online store. You might want to look under the security option of your favorite browser and view a few of these certifying authorities and their public keys. How a digital certificate is used. This slide illustrates that process. Notice that this process uses both asymmetric key encryption and symmetric key encryption. Since symmetric key encryption is much more rapid than asymmetric key encryption, the process only uses the asymmetric protocol to exchange a symmetric private key, which is then used for the rest of the session. The bulk of the encryption is done with this symmetric key. Number 1, a client, that means you, want to send your credit card info to an online store. You log on to the online store with the HTTPS protocol. This is a secure request. The server sends you a digital certificate that is encrypted with the public key of a public certifying authority. In the certificate is the online store's public key. The browser on your computer recognizes the certifying authority and already has its public key, so it decrypts the certificate and obtains the public key of the online store. Number 4, your browser generates a symmetric key and then encrypts it with the online store's public key. It sends it back to the online store. Number 6, the online store decrypts the message with its private asymmetric key. Number 7, now both the client and the online store server have the same symmetric key which nobody else knows. They encrypt and decrypt all the rest of the secure session using this symmetric key.